Happy Wednesday. We are halfway through the week. How's everyone doing? Happy Wednesday. All right. So we are continuing to improve very slowly, very, very slowly, improve our little project here. This will take us quite a while, but that's okay. Lots of fun, lots of content. I love coding. Oh, slept in today. Okay. I woke up just before I was supposed to. The alarm went off. I turned it off and fell back into a dream. All right. So we are building out the tests for a data plane. Data plane is a piece of software that will download, download databases from Data Archive. And it will also stream data from Data Archive to update databases at these databases here, so that an application via SQLite can load and run the data. This is useful for fanning out a bunch of readers in a cluster. So at the moment, we are looking at the read side of data plane, not necessarily the write side. The right side would be watching for mutations and then sending these mutations to Data Archive. Okay. Last night, I refactored some more of the test code. We now have a utils directory for asserting that, well, and it has a number of utilities in it. For streaming a database, populating a database with random notes made of Latin words. It has the 225 lines of test archive server. We also now have a test context. I could see placing things like assert files are equal on to test context. The paths are very specific to it. You would have to get those paths out. Let's just change that real quick. I'm trying to think, do I want this here or somewhere else? Self, we no longer need the paths. Paths are now self.server tempter and self.client tempter. That will have broken something in here. Oh, shoot. But I do not keep a copy. I destruct it. Just because it makes so much of the rest easier. I wonder, maybe more of this should be in there. So we have sync manager. Creating the test DB, that could be on there too. This would be a good time to reorganize this code, because we're going to be creating a number of additional tests. And that's, if we get it how we want it looking now, that's a lot less work later. Okay. Let's see, what would we want here? I'm going to just copy this for a moment before we get too deep. Let's see what it would look like. Let's say we had a test context. And this would be, sync manager is on test context. But what is this doing? This sync manager is in this file. Right, we have a sync manager. That's the client. So maybe we say test context dot run sync manager. We could do that. Now, server events are interesting. How about something like this would be test context dot server event. Something like that. We get the event. Or we could say server event matches, although I think that would be more challenging. Let's leave the matches out here. I think we would have to build up a macro for that in order to wrap the macro. I don't really want to do that right now. Okay. Database created stream. Oh. Something like so. Get the next event. And this could be create server DB. Something like that instead of these. Let's start building these out. Create server DB. I don't think that I really want it to live in here. Maybe we extract it out to its own file. Okay, let's... I'm not sure what we would return here. And create testdb lives in here. Yeah, let's move this. New file, let's call it context. Okay. Da-da-da. So we have our test context. Let's make sure we have access to that. Let's also have run sync manager, which is sync manager.run. Sure. What do we return here? This is unit. This would have been unit. They just abort if something fails. This is test code. Archive server. Create test context. This is kind of the new on test context. It's async, pub async. Where's our module? Let's see. Sync manager, blah, blah, blah. Oh, here. Mod context. Server event. Okay. Did it autocomplete this? Or copilot it? Wow. Okay. I don't really want this to be super server events. I would rather it be path from crates. So I think this exists at use crate DB archive. No, it's tests archive server events sync manager. I think this is the same thing. Let's just clean up some of these. Oops. Okay, sync manager. Where do you exist? You are at use crate DB sync manager. It's a Tokyo sync test archive. Where's create connection? It's an archive server. Oops, oops. Come back, come back. It does not need to be part of this, but it needs to be available. Let's move it closer to where it's used in this file. Channel. Is that a tonic transport channel? I think so. Oh, yes. This is mutable self. Oh, run consumes that. So we could store that in an option, take it, and then run it. We do need to change when it actually runs. We can't just run it at startup. Sometimes there is some test prep before we run Sync Manager. Self doesn't exist yet. Okay, just a couple of errors. You can see the errors on the right here. Oh, interesting. Now the database name was not passed in here. Test DB, where did I dump that? Is that in here? No, that was in util. Hmm. Is to be mutable. Okay, almost there. Great. Now let's go back to the test and work on that last test. Run sync manager, boom, done, fine. Server events should still be there. Oh, this wasn't awaited. Perfect. So we create a context, we run the sync manager, we wait for an event, wait for another event that we pull a stream out of. Then we wait another event. Good. These events match what's happening on the server. So the server can tell if the client is doing the right thing by emitting events that represent the calls that the server is receiving. So we can tell that the client is calling the server in a correct order. And then we can also stream data back to the client, because the test server rather. Hey, CodaFan, I am still on Starlink. And I could see that 2 minutes ago, we had a little blip. Let's see. So create a database and send it to the client. Here we create it. Great. Server events. This is going to be test context server events. How have you been? It's been a long time. Oh, we don't invoke await. Stream database. Yes, this should be on context as well. We just tell it stream server database. Where did stream database go? Is it in context already? Oops. It's not. Is it in utils? It is. Beautiful. Okay. That feels reasonable. I don't really like the name test context, but it's our little test controller. Okay. So let's replace test database stream, which is this one. Let's okay. This is supposed to be at the bottom. Great. And this one needs to be updated. That needs to be immutable test context. Great. Server DB. We'll call it database name. Is that async? It's not. I do that sometimes. I'll hit the pipe on there. Okay, so we've got those. Okay, perfect. I like the look of these tests much better. We create a test context. Now, when somebody comes in and they say, "What the heck is this?" Hopefully, they can see that, hey, we're running Sync Manager. Sync Manager exists up in this file. We're getting a server event. Comparing a server event. Creating a database file. Yeah. Something like this could be impuled on the at enum. I think it's okay for now. Okay. Now, if we go back to, let's look for run. When the sync manager is run, we create a little loop. It runs this, it calls this function called run sync manager. Run sync manager ends up calling run database stream and sync databases. Okay. Run database stream spawns this. Where does it get the connection? Archive connection. Okay. Yeah, so it ends up monitoring databases on disk. If a new database is created, if it's removed, that's kind of what it's intended to. Additions and deletions, we don't actually handle the deletions yet. So it just produces a stream of information that somebody might be, that need to be synced. So it produces a stream of database names that should be synced. And the next step is to sync the databases. And this is the client. By the way, this is not the server, this is the client. So we call sync databases, given that stream of database names. Instead of sync databases, we loop over each one of those database names that we receive. Now, this is what we've really been testing. Thus far, we've covered this branch. And that's it at the moment. The next portion is to say, we have a database. Its checksum is currently this. Please give me data. Please give me the out-of-date pages for this database. And so what I'm expecting is that, let's see, where's Sprite? Oh, yes, glorious little UFO image. Let's go back up to the top here. Sorry, this is our blackboard, our whiteboard. Okay. So the server will have, for a given DB, let's say it's DB, in the test code, I call it happy, right? Happy, that's an A. Happy.db3. Well, that's a DB3. Right, so the server will have this stream of data on it. And it will be able to say that each one of these are the pages. They are not in order. This is a sequence. This is how the database changed. Okay. So at any given point, we would have a checksum. So we have the checksum, and then we have page by page by page, each identified by a checksum. And this might be page 1. This might be page 3. And then we update page 1 again. 5, 1, 7. I said 7 and wrote a 3. That's great. 1, right? And so on, right? Maybe this is 2, 8. And so when somebody says, I have checksum 13, which might be right here, we would need to stream pages 8, 2, 1, 3, and 5. We would not need to stream this one because a more recent page of that number already exists. So basically we would read this log backwards, starting here, moving in this direction until we get to the page that, or the checksum that the client has. There would also be a data structure that keeps track of these checksums, and possibly a compaction process that also, as you could see, condenses the log. Okay. That's the idea. That's the idea. We have not implemented the server yet. We're just implementing how we want to interact with the server. I have this checksum for this database. Give me the updated pages. Okay. So let's start to create this. We're going to use happy again. In this case, we will need the same exact file in both places. Hmm. Let's set up the databases first. Okay. Create a database. In both the server and the client. Hey, how you doing, sign up? We will create an identical database. After that, we will start the system. Oh, no, we need to update the server portion. So the updated pages. Okay, this is basically the flow we will go through. I need some water. Just a moment. All right. So let's create a test context. Now, what we need at this point, so we need to create the database in both places. Right now we have create server DB. We don't have like a copy server DB to the client. I want it to be expressive when somebody's reading the test code. I want to see that, you know, a database file is created on the server and then it's copied to the client. And or at least, you know, the test code does it in preparation of a test. Copy server DB to client. Self. Database name. Thank you, Copilot. Create the server database. Let's call it happy again. Oops. Now we will copy that to the client. Okay. And now we start everything up. So we'll start the server context. We'll start the client piece. So we want to run the sync manager. We will get some pieces. I'm going to take some of this. So we run the sync manager. We get an event that says, hey, the server received a request from the client, from the sync manager, asking for the stream of databases. Great. We get the database stream. See, we could either respond to this event saying, hey, this database exists. Right? Or we could respond to this one to get databases. I think I would rather respond to the latter. Actually, I don't have to because the test server already has the file because we created the server DB. That's right. Okay. Oh, wrong one. Here we go. So the client starts a stream to listen for database additions or removals. It then asks for the list of the databases. It asks for information about a database, but it should not call fetch database. This is where things change. Okay. If we look at, where was it? Sync database. So before we were just downloading it, right? But now the database exists. So it's going to come into this other branch. This branch here, we should ask the server to start streaming the database changes from a specific checksum. And this is our .proto file. We're using Tonic with gRPC. Okay. Thus far, we've got get databases, database stream. Those are done. Database info, that's good. Fetch database. This is just downloading the database. We don't have it. Give me all the pages. But this one here, stream database updates. We have not asked for that one yet. We send it a stream database request, which is the name and the checksum. And we are expecting a database update in response. I don't really like the name of this. Maybe a database page would be more accurate. Because, as I said before, the server will simply start at the end of the stream and start moving backwards until it's identified all of the pages that it needs to send because it will reach a certain checksum. Right, we don't need to send this one because it was already sent here. Let's call this database page. Let's rename this. Oops, wrong way. So we get the number of the page, we get the data, the checksum of the data, and then the checksum of the entire database after the page has been applied to it. This is interesting in that this won't be helpful. That won't be helpful because we would need to stream the pages from left to right instead of right to left. So maybe we do that. Basically build a list of pages. We need this one. We need this one. We need this one. Oh, I'm sorry. 1, 2, 3, 4. We need 5 pages, and then we start streaming them from left to right. So we build a list. And then we send the list. Now, the reason we would do this is so that we can ensure the database is in a consistent state with the archive server after every page has been applied. We never, ever want to have the database corrupted. So this is the process we'll go through. The nice thing about this is, even though, like, if you don't have the database, we just stream you the latest version of it. Great. That's every page in the database. If you have a copy of the database and it isn't ancient, then we will only send you the pages that bring you up to date. Oh, but you know what? Applying this page, the checksum would be wrong because we would omit this one. Because this one's omitted here, this number 1 is omitted. This data hasn't been applied, so this checksum is bad, which means that the checksum would only be valid once we get to the end. The database checksum. Okay. We might see that it's okay a couple times throughout here. But here it would be broken. Or rather, sorry, I did that wrong. So here it's broken, here it's good, and here it's good. I guess all of these would be good. Drawing with the mouse is hard. Okay. No, I like this. I really like this. I think it'll work. It's simple. It can be optimized. I think that's a good name. It's a good name. Okay. Now back here. I was just wondering what to call it. I think this is a good name, Stream Database Updates. I don't know about this Copilot autocomplete. Let's look at this. What did it give us? Okay, so connection name and DB info, just like we had for the other function. Hey, what's it? Is that Skizbilly or Skysbilly? How are you? And today we are working on data plane. It is part of, I guess it's part of a platform. I don't know, a new stack. I'm being ambitious. Excuse me. It's part of a new stack, and that stack is built upon SQLite, a proxy, and a database replication system that we're building out called Reverb. At the moment, we are inside of this thing called data plane, which is this guy right here. There's two of them. In one case, it sends data to the data archive, and the other, it receives data. And we are working on the receiving part. So we're looking to get updates from the stream. Do we need to fetch database? No. We're trying to call stream database updates. And that's going to be called a stream database request. Stream database request. Wait, is it? Is that the right one? Yeah. Because then after we're up to date, the stream just continues. It doesn't actually stop. Maybe it should. Maybe we need this and something else. Because in one case, we want to know that we have received all of the pages since, or between two checksums. And then we want the stream since a given checksum. I'm trying to talk myself out of it. So at some point, we would send a status update to the server saying, hey, this is done. But we don't know to go on to the next database to update because the stream never ends. Let's see. It's like we want two slightly different versions of this. One where the stream, we just keep listening, right? We say, I'm at this version, stream me all the data. Another version saying, hey, I'm starting up. Give me the updates that I need before I start the application. Right? There's a subtle difference. It's that the part where I need to know that I'm up to date. Maybe we could solve for this with a little bit more information in the response. this here could have something in it that identifies this is the most current piece. Right? Is this the last page? Something like that. Or the last piece of the stream. And as long as you get close, I think we would be okay. Because we could stream until we get to this point. Right? And then we could go from one to the other. What are we working on? I should create a clip for this. No, it's funny. We're working on. Let's see, where is it? This platform I'm calling Reverb. It consists of a proxy, a VFS plugin for SQLite, a data plane, data archive, and cluster management. So think about it as a platform where developers get to focus on writing apps, and the scaling and sharding and handling load is automatic. At the moment, we are working on data plane, trying to get data from data archive. These are SQLite databases. So the context here, this database page is a chunk of a SQLite database. And right now we're reasoning through getting the latest portion of the stream. So somebody might say, oh, I'm at checksum 13, right? Give me the latest pages that I need. Let's see what that looks like. Okay. It's only 8 more bytes. It's not going to break the bank. If it's even 8 bytes, I don't know. I'm not sure the wire format of protobuf. What does that look like? No, I don't want that. I want, what does it look like? A simple message. Wow. So bools and enums are both encoded as if they were I32s. Okay. All right. Well, I'm getting a little distracted with that. Let's go back to the code. Because I already have this function here. Stream database updates. I think I must have it twice now. Yes, I have it twice. Okay, let's get rid of the one that Copilot wrote for us. Which one is that? Probably imagined one from the other. This one. It's got this. Now, if this fails for some reason, we want to fall back to just downloading the database. I wonder what kind of error we would do for falling back. Let's see. Let's see. Maybe we return a Boolean saying, hey, it doesn't have it, or we got this error. I wonder what kind of errors we can send back. So this would be like a tonic status error. You give it a code, string, details. Okay. What would the status be? Are gRPC statuses the same as HTTP statuses? Status codes. Not, oh, well, we could say not found, right? Or out of range, saying, hey, this checksum. Okay, there are options. Not found works for me. So if we get an error back, it says, hey, this was not found, then we know that the checksum wasn't found. How do we know if we asked for a database that wasn't found? Maybe that's not found, and then out of range is for the checksum not found. Oh, I like that better. So name not found, checksum not found. Okay. Let's go back to Z. Close that. Oh. So first we ask it to stream the database request, to stream the database. That is here. Stream database request. We give it the database name and the checksum. Where does this information come from? The DB info. Why would we use that? Is it something that we found? Oh, that's a response we got back. We need this to be the actual checksum of the database that we have locally. So in these cases, we can use that because the database doesn't exist locally. Move that in here. But there is an optimization. If the local checksum is equal to the server checksum, then we can go straight to, well, streaming, which whatever. Okay, it can go through a file check. That's fine. Okay, I talked myself out of it. In this case, we don't want to pass the DB info in. We want to pass the checksum of the database that we have locally. Let's get rid of that. We do not need DB info. We need to use, does this struct have, it does have checksum. Okay. This here is a data structure that we use for checksumming the database. It's supposed to stay up to date. I'm not really keeping it up to date. I'll have to reason through that later. Because as we write pages, we should be updating checksumdb. And we are not doing that. We are approaching the hour, though. And I need to wrap up. Apologies for the abrupt end. I lost track of time. Let's see. Are we going to raid someone today? So yesterday we raided Brooke Zerker. Let's see. Who's doing Rust? All right, let's, well, I gotta go. We're gonna raid the Primogen. So until next time, y'all, take care. Bye-bye.